The quadrilateral family. And there's a little bit of a tree diagram of the family. But basically, you classify quadrilaterals with the features that they possess. And the more features you know about it, the more specific you can get about the particular shape. So as you branch down, they become a bit more specialised in their features. So any property that you know can be used for anything that branches from it as well. So for example, a rhombus branches off a kite, it branches off a parallelogram. The parallelogram branches off the trapezium, and they all branch from the quadrilateral. So in fact, a rhombus would have all the features of a quadrilateral, a trapezium, a parallelogram, and a kite. You could use any of the features from any of those shapes if you know the shape is a rhombus. Well, what are the different features? So we start at the very top. A quadrilateral. A little bit boring. It's got 4 sides. That's about all we know, really. Got 4 angles as well. So hence the name quad. Quad meaning 4, lateral meaning length or side. Okay, so it has no specific properties, really. Okay, so let's branch off one way. We go to our kite. Okay, so the first thing we know about a kite is adjacent sides. So you've got a pair of adjacent sides that are going to be equal, and you in fact have 2 pairs of adjacent sides that end up being equal. The diagonals in a kite are perpendicular. Now that's one that's often mistaken to be a feature of a rhombus. But it's not a feature of a rhombus, it's actually a feature of a kite, and of course a rhombus branches off the kite. And similarly, the area formula, again, mostly mistakenly said to be the formula for the area of a rhombus, but it's actually the formula for the area of a kite. And again, because the rhombus branches off the kite, we can use the formula. So a half xy, where x and y are the lengths of the diagonals. Now over on the other side, we go to a trapezium. What do we know that? We know that a trapezium has 1 pair of parallel sides. And our formula, half the perpendicular height, and then the sum of the 2 parallel sides. Parallelogram branches off the trapezium. So you could use the trapezium area formula to find the area of a parallelogram. I don't know why you would, but you could. Let me show you. Let's first of all look at the features of parallelogram. We know it now has 2 pairs of parallel sides. But we now know that the opposite sides are going to be equal. Once it's a parallelogram, we know that. And opposite angles will also be equal in a parallelogram. The diagonals in a parallelogram will bisect each other. And the formula for the parallelogram we tend to use is base times perpendicular height. So you can see why we could use the trapezium formula if we wanted to, because there's perpendicular height h. Well, a plus b, the parallel sides are going to have the same length. So when you say sum of the parallel sides, you'll get twice b, and then times it by a half, there's your base times height. Okay, if you want to prove a shape is a parallelogram, yes, you could prove any of these particular features. There's also an additional one. If you only know something about a pair of opposite sides, and you know they're both equal and parallel, then that's enough to say, yep, this shape is a parallelogram. All right, so kite, parallelogram. Parallelogram then comes down to rectangle. Now we know the angles are actually 90 degrees. So our parallelogram stops being floppy, if you like, and becomes nice and straight. And now the diagonals become equal. And we get length times breadth for our formula for the rectangle. Rhombus is both a parallelogram and a kite, so it has all those features, but in addition, the diagonals in a rhombus will bisect the vertex. Now this is the mistake people make with a parallelogram, and often people say that in a parallelogram. Not true for a parallelogram. It's not until it becomes a rhombus that the diagonals will bisect the vertex. And then we have, I guess, the perfect quadrilateral, the square. And it doesn't really have any of its own features other than all the features of the ones above it. And that is that area is equal to s squared, if you wanted to. Oh, by the way, you might be thinking, why didn't I bother with the rhombus saying that all the sides are equal? And the reason I didn't is because it branches from the kite. The kite was adjacent sides are equal, and it branches from the parallelogram, which says opposite sides are equal. So if both the opposite sides are equal and the adjacent sides are equal, we get all the sides are equal. So that is certainly true of the rhombus, that all the sides are equal. All right, I wasn't going to do any actual examples there, just a handful of